Hello everyone and welcome to the NPTEL course in Pharmacognosy and Phytochemistry. In this session, that is the session 5 of week 8, we are dealing with a compounds that or a set of compounds that are intensely bitter, but they have been derived from a very unique species, and that is ants. So welcome to the world of iridoids and iridoid containing drugs. So what are iridoids? Iridoids in nature are actually monoterpene derivatives. Now if they are monoterpene derivatives, why aren't they classified under monoterpenes? So this monoterpene derivatives do get cyclized in a slightly different but a definite manner. So if you see this particular iridoid nucleus as represented by iridoid alcohol, if you carefully see, you can still spot the monoterpene. So if you remember, monoterpene are compounds which are dimers of C5, that is you require 2 isoprene units. So this is my first isoprene unit and this is going to be my second isoprene unit. So you have a proper C10 nucleus, you have a proper isoprene joined to head to tail manner, but they are not classified under terpenes for the reason being when they cyclize they involve a heteromolecule. So you see that they have formed a 6-membered pyrene ring and a 5-membered cyclopentene ring which are fused to each other and carry 2 methyl branching. So we have this typical nucleus which has a 5-membered cyclopentane and a 6-membered pyrene. Each of the rings having a methyl group is characterized as a iridoid nucleus. Now iridoid nucleus has its aspiration from a compound called as iridomyrmecin. Now iridomyrmecin was actually discovered with Iridomyrmex genus, which is a genus of ants. Now Iridomyrmex genus is something which gives you a strong stinging effect, and there was a lot of there was a lot of research which has gone to find out what this compound was, and eventually the compound found was your iridomyrmecin, and iridomyrmecin was found to be a iridoid compound, or that's where they get their compound name as iridoids. So anything that has this central aspiration of iridomyrmecin as a nucleus, or as we call it as a pharmacophore, belongs to the category of iridoids. So this particular pharmacophore or this particular nucleus contains cyclopentanopyrene nucleus, or more specifically dimethyl cyclopentanopyrene nucleus. So where are these iridoids coming from? Now since we see a proper head to tail condensation, needless to say they are prepared by cyclization of geranyl. Now this geranyl also involves an additional oxygen, and that's where you get this pyrene oxygen from. Now initially it is thought to be a geranyl derivative, but after the geranyl is produced in your acetate mevalonate pathway to prepare iridoids, there are like 27 different branches or 27 different routes from which different set of iridoids can be prepared. Now this iridoid nucleus contain cyclopentanopyrene, and they are located in different families of plants. This include your Corniflorae, your Gentieliflorae, Lassiflorae and your Lamiflorae superorders. So they belong to your Corniflorae, Gentianiflorae, Lassiflorae or Lamiflorae superorders, and in those when you have your families or you have certain species of plants, especially those growing in the temperate regions, those you will find your iridoids occurring very commonly. Not only that, amongst that you will find your iridoid glycosides also occurring more commonly, where the glycosylation happens at the hydroxy group. Now in terms of numbering of iridoids, the numbering of iridoid goes with your hydroxy taking the first position, the O of your pyrene taking the second position, this is represented by third, fourth, the bridge carbon has the fifth one, sixth, seventh, then you have your eighth, ninth, that's where your ring is over, okay, and then you have your 10th. Okay. Now depending upon the different nucleus, now you will ask that why not 11? You can give the name 11, but we are not giving it, the reason being that we are putting it oxygen a number, and in order to compensate for that we are giving one less number, but in some cases where you want to substitute or when you want to add, you can even denote or annotate this as 11, that is also perfectly alright. Now if you go to see classification of iridoids, the classification of iridoid is that if the nucleus is kept as such, that is if you have your cyclopentanopyrene kind of nucleus, that is the primordial or the prime one, or that is the most common one. Now in some cases what happens is there is a demethylation happening. Now when the demethylation happens, you get one less. So from C10, which is this, that is 10 carbon compounds, you get 1 carbon less, which is C9, you get second carbon less, which is C8, and in some cases what happens is a 4 carbon moiety gets stuck to it, and in that case you call it as a C14 derivatives, but nonetheless your cyclopentanopyrene nucleus still exists. Now in second case what happens is sometimes the bond between the 7th and 8th gets broken, and what you can see as a result is if you just break this bond, then you will find that your 10th and 8th are joined, whereas 6th is joined to 7. So you get what is called as an open ring. So your cyclopentane is no longer there, you just have the pyrene ring left with it. Such type of iridoids are called as secoiridoids. Now in some cases it might also happen that this will cyclize with this maybe by a formation of acetate or esters. Okay. So that might be an ester linkage, and it might so happen that your 7th can kind of cyclize with what you saw as the 11th or the methyl substitution on 4, and that is also still classified as your secoiridoid type. A good example of that is your secologanin, which is involved in the biosynthesis of certain alkaloids. So let's see the physical properties. Like I said, this compounds are irritating. When you consume them, these compounds are bitter. In nature, they are colorless. Some of them, because they have sugars attached to it, are soluble in water, but most of them are soluble in ethanol, acetone as well as methanol. Some of them occur as glycosides. Even in certain cases, the epoxides of your iridoid compounds are also found in plants. Now, if you see comparatively, like we discussed here, the compounds when they are in native form are very unstable and prone to rearrangement, but the moment they are converted into their glycoside derivatives, they are much more stable. The aglycones are more susceptible, and they are susceptible to acids as well as enzymes. Whereas if you see derivatized or acetylated iridoids, they are more susceptible to alkali. Now also one more thing is observed, iridoids as compounds are colorless, but when you treat it with acids or when you treat it with enzymes or in presence of oxygen, they form complexes with acids, they form complexes with each other, and the end product is a bluish or a violet blue color compound which is no longer soluble in water. Even if it is a glycoside, it still kind of precipitates out, and that is a typical property of iridoidal compounds, and that is the reason you to be very careful while dealing with iridoid compounds, that even during the extraction stages you are not exposing them to harsh acids as well as alkalis. Now going to the first example of drug containing iridoid, The first example of drug containing iridoid is gentian. Now gentian has a lot of species in the Himalayan region. About 400 such species are known, and the most common medicinal plant in this category is your yellow gentian, or often referred to as your Gentiana lutea. Now what is done is you dig these plants. The plant is generally cultivated or allowed to grow in wild for a period of 2 to 5 years. Once the plant is matured, your roots and rhizomes are kind of acquired a certain thickness and girth. In that case, you will dig it up, and then this is dried, sliced and used as your gentian. They belong to the family Gentianaceae. Now this plant is found in most of what is called as the temperate regions. This includes your Central and Southern Europe, Turkey, Yugoslavia, France, Italy and Germany. Okay. This is the image of inflorescence of yellow gentian. The other species show a different colored inflorescence. Now what does it contain? It contains compounds which are belonging to secoiridoids. Now if you recollect secoiridoids compound, here you can see you can still retain the pyran nucleus, but what has happened is your cyclopentane nucleus is vanished. So in this case, or gentian contains secoiridoidal compounds, wherein the 7 is protruding out. Now this contains beta glycosides. So most of the, or most abundantly, you will see glycosides of secoiridoids. A good example is gentiopicroside. Now this is the one which is more abundant in the plant, to the extent that it is almost 2% in the dry root or the rhizomes. Now you will see the second one, Schwarzschier marin. Schwarzschier marin is nothing but just a hydroxy derivative of gentiopicroside. So gentiopicroside is major, hydroxy gentiopicroside is what is called as Schwarzschier marin. Now in some cases what happens is their derivatives referred to as bisphenolic. So these are two phenols, or often referred to bisphenolic, and then there is an acid. So you have bisphenolic acids being attached to here, this part of glucose, and if the attach or bisphenolic acid attached to gentiopicroside, you get a compound called as amarogentian. Amarogentian is considered to be highest bitter or intense bitter compound present in this plant. Now if you take an example of Schwarzschier marin, and to that if you add your bisphenolic acid, you get what is called as amarosverin. So these 4 compounds are secoiridoids. They are more specifically secoiridoidal glycosides, gentiopicroside and Schwarzschier marin, and the derivatives amarogentian and amarosverin are bisphenolic acid derivatives of gentiopicroside and Schwarzschier marin respectively. Now you can take gentiopicroside and cut off the sugar. When you cut off or when you remove the sugar, you get a glycone, and this a glycone is referred to as gentiogenin, and for Schwarzschier marin you have your hydroxygentiogenin. So these are 2 glycones which you get on hydrolysis after breaking the sugar. Now the color or slight yellow color of the underground parts, especially the roots and rhizomes, is attributed to presence of xanthones. Different xanthones are present in your gentian, and this include your genticin, gentiamarin, isogenticin, gentioside and gentisic acid. They all contribute to a yellowness. Now if you see, or if you categorize flavones as well as xanthones, they show some color attributes, and this specifically this particular set of xanthones have a yellow color, which is also seen in the roots and the rhizomes. Now where do you use this? Now most of these plants which are intensely bitter, are known to be stimulants, especially GI stimulants. So this GI stimulants stimulate gastric secretions. This GI stimulants stimulate your bile acids, and that is how they act as your bitter tonics. So iridoid containing drugs are very famous for their effect on your stomach as bitter tonics. Apart from that, they help you with management of numerous digestive disorders. This includes loss of appetite. Definitely when the secretions are going to increase, your appetite automatically increases. They help you deal with intestinal gas as well as diarrhea. Now apart from that, the compounds present in your gingea also show anti-inflammatory wound healing activity. Like I said, because they are bitter tonic, they secrete bile secretion, so they are under or categorized as chloractic. They are antioxidant. Now another advantage of iridoids is they have a very good protective action on liver. So they are known as hepatoprotective. They prevent cirrhosis, necrosis, and have a very beneficial healing effect on liver, and that's the reason they are called as hepatoprotectives. Apart from that, they show antifungal, and they help you in management of anorexia. So these are few applications of your gentian, and very similar uses you will find to another plant which is more native to us, and that's your picrorhiza. Picrorhiza, or commonly referred to as kutki. Kutki is obtained from dried roots and rhizome. The roots are very tiny. More predominantly what we take are rhizomes of Picrorhiza curva, and it belongs to the Scrophulariaceae family members. Now this is a plant which is very abundantly grown as well as cultivated in the Indian Himalayas. So you will find it growing right from Kashmir region down to Sikkim region. So this plant is dug off, and the rhizomes, which are cylindrical, as you can see the image, irregularly curve. And the interesting part is, in the rhizomes, wherever you see the nodes, the rooting generally occurs, or the rootlets generally occur at the places where the nodes are located. So that's one way in which you can identify Picrorhiza rhizomes, or that is how they stand out. Now what do they contain? They also contain iridoids, but these iridoids are more of what you call it as cyclopentanopiron. Previously in your gentian we saw secoiridoids as the chief components. For your picrorhiza, we have your cyclopentanopiron derivatives as your chief compounds. So you have your picroside 1, 2, 3. Picrosides generally have a cyclopentanopiron nucleus, but in addition to that, you can see here there is epoxide present, again making them slightly unstable. So you have to be very careful while dealing with these compounds, especially extracting these compounds. You cannot deal with strong acids and bases, as it may affect these linkages. Now what happens here is, in some cases it is attached to what is called as vanillic acid. So picroside 2 has vanillic acid being attached, whereas if you see your picroside 1, both of them are glycosides, but you have your cinnamic acid attached. So this has cinnamic acid, whereas this has vanillic acid. So when they hydrolyze in your plant, your cinnamic acid and vanillic acid are also present in their native state, and also the hydrolyzed products. Apart from that, you have your kutkoside, which is also a iridoid compound. You have your kutkin, and you have derivatives such as kutkisterol, epocinin, ferulyl catalpol, apocynin, mincoside, pysine, androsin, cinnamyl glucose. Cinnamyl glucose chiefly comes from this breakdown. So you have cinnamic acid plus glucose, and you have your other phenolic glycosides. So this all contributes to the total effect of Picrorhiza curva, which is also used as a bitter tonic, and it is very famous in Ayurvedic system of medicine for this particular action. So let's see where all it is applied. So it is used as a bitter tonic. If you take it in a little higher doses, it acts as cathartic as well as purgative. So you have to be careful. It is a stomachic, and one thing about Ayurvedic medicines is the medicines mostly which have a bitter note to it have also been associated with antipyretic effect. So this drug being a bitter shows antipyretic effect. It is reported to possess antiperiodic, cholagogue, febrifuge as well as anti-malarial properties. Not only that, it is used as an emmenagogue, emetic, abortifacient, so you need to be very careful, and also it is used in treatment or as antidote for dog bite, so that the infections don't spread in. So these are two little examples of iridoid containing drugs, but if you wish to read more about this set of compounds, you can refer to the following books. So thank you everyone for your patient listening.